Hey Mustangs, in this video we're going to be taking a look at some simple math skills that can get you some easy points on the AP exam. Now this is going to be the last video of the year, so I just wanted to say thank you for an awesome year. It's been a real honor having you guys as AP students, my first AP biology class, and thank you for all the hard work that you've put in this year, and good luck on your AP exam. So let's go ahead and take a look at those math skills. All right, so first thing that you want to be careful with on the test is you want to make sure you're giving the answer the way they want you to give the answer. So if you take a look here, these are some possibilities of what they might be asking you. So if they want a whole number to the nearest tenth, to the nearest hundredth, or nearest thousandth. So I don't have my tablet with me, so I'm going to write with the PowerPoint pencil here, PowerPoint pen, so bear with me on this. So let's say the nearest whole number. So let's say you get the number 13, what's horrible, 13.7286. Okay, so that's a 1 and a 3, so 13.7286. The nearest whole number, well, if you look, the nearest whole number, there's 7, so the nearest whole number would be 14. If you were to bubble it on the grid, you could start here. You could put a 1 and a 4, or you can go on this side, a 1 and a 4. Either way would be correct. So you could put 1, 4, do it, and bubble in a 1 and a 4. And you could have put it over here too, a 1 and a 4. So either position would be correct, all the way starting on the left or all the way starting on the right to do your answer. To the nearest tenth, so remember this is the 10th place here, so it's a 2, so the answer would be 13.7. Wouldn't round up, you'd round down in that case. So here, if you put a 7, this would be the point, this would be the 3, this would be the 1. So then you just bubble in 13.7, or you could have done here 13.7. Again, either way, you can start left or right in order to fill it in. Nearest hundredth, so there's the hundredth position here. Look at the next number, that's an 8, so this one would be 13.73. And if it's to the nearest thousandth, which is this place here, it's a 6, so that would become a 9. So 13.729. So looking at this, you want to make sure that when you are going to give an answer on the grid-ins, that you look at what they want you to round to. If you don't, you might do all the math correctly, but you bubble in, they ask for the nearest tenth and you give them to the nearest hundredth, you just got it wrong. So make sure that you slow down and you look, the nearest what? What are they asking you to do? All right. Another skill that's a really easy one is how many times greater. So you'll see several questions that will say how many times greater is this, how many times larger is this, or how many times more is there that you're looking at. So as an example on this one, it could be in numbers or it could be in graphs. In either case, let's say you have, let's get the pen out again here. So let's say you have a graph and there's a number, a bar here and a bar there, and it's giving you information. And let's say over here it corresponds to, let's say, 23, and over here this one corresponds to, let's say, 74. So that's where this is, and that's where this is. And then the question might say, how many times larger or how many times greater is this compared to that? So all you do in these questions where it asks how many times greater, how many times larger, or how many times more is something, you take the larger number and divide it by the smaller number. That is it. That's all you have to do to get how many times greater. But you have to be careful because the numbers they're giving you to start, like on a graph, yeah, this is really easy. You just take the larger divided by the smaller and you get your answer. But if they give you like numbers, but then you have to find volume or surface area or some other calculation first, you'd have to solve for that calculation first, then take the larger number divided by the smaller number to figure how many times greater, larger, or more it is. So here in this case, if we were to do this out, let's say we divide and we wind up with 3 point 217. And let's say they want it to the nearest hundredth. So in this case, we'd have to grid it in as 3.22. So we go here, we go 2 there, 2 there, point, and a 3. So this is 3.22 times larger than you just bubble it in. Okay? It might be on a graph like this too. So you might see like a line go like this, and they say, okay, the point here and the point here, how many times larger is this compared to that? So once again, you look. So let's say here we got 13.4. And then let's say this one corresponds to like 5.7 or something like that. Right. So then all you would do would take 13.4 divided by 7, and you should get like 2.35. I missed my tablet. 0. So much easier with a tablet. So 2.350, and then round to whatever they're looking for. And that's how you do times greater. So take the bigger number divided by the small number, and that's how many times greater it is. All right, mark and recapture. So with mark and recapture, if you solve for a mark and recapture in a certain population, you can apply it to larger populations as well. So for example, let's say in a population of, pen here, in a population of 150, you mark and then you recapture, and you basically only capture 35. Okay. Well, that can correspond to the larger population, and we could say, what if you recapture 120? How big was the population that you got it out of? So again, in a population of 150, we marked and recaptured, and we only recaptured 35. So that should correspond to a larger population as well. So here, you basically set it up as an algebraic equation, turn the question mark into an x, and then solve. So then you can go times x. So you get 35x equals 120 over 150 times by 150. I will never badmouth my tablet again after this. So then you get 35x equals 18,000. Never writes the same. So 18,000 there. Divide by 35, and then x would equal, in this case, 514.28, and so on and so on. In this case, they probably wanted you to round to the nearest whole number. So 2 to 4 there. That means you would get 514 as your answer. So then you bubble into the grid, 514, and there you go. So that's mark and recapture. All right, Hardy-Weinberg. With Hardy-Weinberg, there's always Hardy-Weinberg on the test. So make sure you know how to do Hardy-Weinberg. So here, if you're really lucky, they'll give you actually the Q squared, which is the percent of the population that is homozygous recessive. If you're not so lucky, they might still give it easy. They're all actually easy once you learn how to do it. But here they say 24 out of 24 birds show the recessive condition for a beak. So it's not giving you the percent, but you can calculate the percent by finding out the total and dividing by the total. So here, if you read the question carefully, if you want to pause it and read the question carefully, here's how you would actually solve it though. So you would go 24 plus 63 that adds up to 87. So 24 plus 63, so there's 87 in the total population, and only 24 of them have the recessive condition. So you take 24, and that's the recessive. You always look for the homozygous recessive ones. So 24 divided by 87, that is going to get you 0.2758. Okay, so that is Q squared. So that's what Q squared equals. That's equal to Q squared. Take the square root to find Q. If you take the square root, you should wind up with 0.5252. So you could keep that, but I like to round at this point. So Q would equal 0.5, and again it's 525, so I'd round to 523. That means P would equal 0.47, right? So looking at that, we have Q and we have P now. Now all you have to do is figure out what they're asking you. So if this population is in Hardy-Weinberg equilibrium, what is the frequency of the dominant allele? That's actually really easy. So they're not asking you what is the genotype frequency, what is the percent that's heterozygous, or what is the percent of the population that's homozygous dominant. It's literally just asking you for what's the dominant allele frequency. P is the dominant allele frequency. Q is the recessive allele frequency. So we just found our answer right here. Now, if it did ask you for what percent of the population is heterozygous, for example, that's when you plug it into 2PQ. So you plug in 2 times 0.47 times 0.53, and you solve that way. If they asked what percent of the population is homozygous dominant, you plug it into P squared. So 0.47 squared, and that would give you your homozygous dominant. All right, so in this case, you'd go, let's say 0.47 is what you'd get there. I'm bubbling. All right. Finally, if they ask you for the rate of something, rate of change, rate of this, anytime they're asking about rate, it's rise over run. So it's simply calculating slope. So if you see a question like that, then it's rise over run. So if you remember how to do that from math, all you do is take the y values and subtract them from each other, and divide it by the run values, the x values, and subtract it from each other. So here, when we look at this graph or this question, hydrogen peroxide is broken down to water and oxygen by enzyme catalase. The following data were taken over 5 minutes. What is the rate of enzymatic reaction from 2 to 4 minutes, round to the nearest hundreds? Okay, so here we take a look, and it's asking for 2 to 4 minutes. So 2 to 4, and this is literally the x and y values that we have here. So here, when we look at this question, the x values are here. So here's the x, here's the y values. So rise is y, x is the run. So again, when you look at a graph, this is the run, this is the rise, so x and y values. So what you do is, we're looking at 2 to 4 minutes. So the rise would be 5.5. So if you see at 4 minutes here, it's 5.5, minus at 2 minutes it was 3.6. So 3.6. The run is 4 minus 2. Okay. So if you calculate that out, it winds up at 1.9. It's a 9 divided by 2, and then your final answer you get, and it's to the nearest hundredth, 0.95, and that's your rate right there. So that's how you calculate rate whenever they're asking you about rate of something. So you basically calculate the slope.